Great. So we're on question 5 of the grade 12 June 2025 math paper 2. Question 5 is saying in the diagram below, the graphs of f of x equals cos x plus m and g of x equals sine bracket x plus n are drawn on the same set of axes for x is an element of negative 240 to 240. So we have our g graph here. Our g graph is a sine graph and our f graph here is a cos graph. So a is the x-intercept of f and has coordinates of 60 and 0. B is the turning point of G up here and has coordinates of 60 and 1. So question 5.1, determine the values of M and N. This is a 2-mark question, which means we can just interpret our M and our N over here. So a reminder that the easiest way to interpret most of the graphs is by covering up this whole negative portion here and knowing our standard forms. I'll erase that now. But once we can compare things to the origin in the positive side, it makes it a lot easier for us to understand what graph we're dealing with and what shift has occurred as far as the M here, the Q, the shift in the Y-intercept, as well as the N, the horizontal shift. So off the bat, we have our sine graph over here. Our standard form is something like this. We have one crest, we have one trough. Here is positive 1 and here is negative 1. This is 90, that is 180. We have 270 there at negative 1. And then we have 360 degrees is the usual form for a sine graph, which means we have 1 equals a sine b x plus p plus q. A reminder that a is the amplitude, which means in this case for our standard form we have a positive 1 that takes us up to a positive 1. If it was a positive 2, for example, it would take us all the way up to a positive 2. If it was a negative 1, it would then take us down first, going to a negative 1 first at the 90 and then going up like that and repeating. So our standard form is positive 1 over there for our amplitude. Our b is what affects our period. So the usual period for a sine graph is 360, cos is also 360, and tan is 180 degrees, as we'll see in another video, but a period of 360. So if our b value is 1, then it means our period fits in 360. If our b value here, for example, is 2, then we'll end up having something like this, where we have a crest and a trough going up to our 1 at 90, then down to our negative 1, and then back at 180. It'll half our period if it was a 2. And then what we have here for a positive p, this guy shifts our starting point from the origin to the left or to the right, which means if this is a plus 90, for example, it is going to shift us 90 units to the left. So that means if we had a negative 90 here, it would be starting over here, and then we'd meet the y-axis at 1, and then we'd go down to 90 and then repeat. So if it is a positive value here, it shifts us to the left. If it is a negative value, it shifts us to the right. And then the last thing, just like our functions in paper 1, a positive q just shifts up our starting point. So if it is plus 1, for example, we'd start at positive 1, go up to positive 2, come back down here, and then meet our 0 there. And then at 360, we'd be back at 1. And it would shift the whole graph up by 1 unit. So we have our standard form for a sine graph, and then our standard form here for a cos graph is very similar, which we're just going to draw now, just so we can compare our sine graph and our cos graph to the different variations we have here. So cos will start here, go down, and then back up, which means we have 1 over here, minus 1 over here, and then it intercepts at 90, 180 is here, 270 is there, and then 360 is here, back at 1, which means we have half a crest, a full trough, and then the other half of the crest over here. Okay, and this would be our standard form for a cos graph. We have y equals a cos b x plus p plus q. So the reason I just wrote out all the letters, the a, the b, the p, and the q, was so that we can see what place is being taken up in this f of x here and this g of x here, because they haven't manipulated or changed all of the letters that we can, like the period, for example, or the amplitude, but they have, in this case, for m, affected the y-intercept. Okay, which means if we are looking at our m value, we can just interpret it. Our cos graph usually starts at a positive 1, but this cos graph, this f of x, that is just cos x plus m. So that means we would usually be intercepting at positive 1, and we are now only intercepting at 0.5 for our f of x graph. It means the only way that we could make this work, based on the fact that we've only affected the y-intercept, is by making the m minus a half, because it used to start here, but now it is starting at positive positive a half, which means we shifted it down half a unit, and we end up with 0.5 at the y-intercept being the starting point for our f of x graph, our cos graph. So then we are moving on to n. N is shifting us in our horizontal for our sine graph. So our sine graph is our g of x over here. Our sine graph usually starts at 0 and then ends at 360. Okay, but this sine graph here, which is our g, is not starting at 0. So the best way, once again, remember we try to cover this all up because it's kind of confusing to interpret things in the negative, because that is not where we have interpreted our standard forms. The easiest way to then interpret our sine graph is trying to find a point that we can shift in order to get us back to 0. So this number here, this negative 30, is a point that is directly on the 0 in terms of y. But if we were to shift this 30 degrees to the right, we would then have a graph that is going up like this and then going down like that, for example, which is the closest move that we can make in order to shift our sine graph back to the 0, back to the origin, to our standard form, which means if this graph has actually just been shifted 30 degrees to the left, it means our n value is positive 30, because a shift to the left is a positive. This p always works backwards. Once again, like we were talking about, if we are shifting it to the left, it is a positive value. If we are shifting it to the right, it is a negative value, which means our m is negative a half and our n equals 30. So we've just earned 2 marks over there. And then 5.2, it says write down the amplitude of f. So our f graph is our cos graph, cos x minus a half. Okay, so we need the amplitude. We can either go half bracket max minus min if we like that method, and then we can solve for it from there, or we can just go ahead and interpret our standard form because there isn't any number or sign in front of our cos x. So we just have a cos x minus 1 over 2. This is the graph that we're looking at. This is f of x, which means there's no 2 or 3 or 4 or anything there. There's also no negative in front here, which means our amplitude for this guy, if we just interpret it, the only change that has occurred is that we have shifted the y-intercept, which means our amplitude is just positive 1 because they haven't put any symbols here or any values or signs in front of our cos x, which just means that it is a positive 1 and that is our amplitude. So now we're on question 5.3. It says if h of x equals g2 of x, write down the period of h. Okay, so here's our g graph and they are saying h of x. So h is the new graph that we are turning this guy into. What they are doing is they are adding a 2 to our x. And the way that we would usually add that is in front of the x and the shift, which means that if we want the period of our h, this number here is now affecting our period, this 2. A reminder that our period is usually 360 degrees when our number for b is 1. But now we have a 2 here, which means for our period, we have to go 360, which is the usual period for a sine graph, divided by 2, this value they added here that affects the period, which means that our period then equals 180 degrees, which means this graph is going to occur in double the time and we're going to get a crest and a trough in 180 degrees instead of in 360 degrees. So that has just earned us 1 more mark there. And then question 5.4, it says for which values of x will f of x times g of x be less than or equal to 0 in the interval x is an element of 0 to 240 degrees. So f of x times g of x is negative. That means one of these guys needs to be positive and negative, or this guy has to be negative and this guy has to be positive, because a positive and a negative going both ways will ultimately make this guy negative. You can't have a negative and a negative or a positive and a positive, because that will not satisfy this equation considering they are multiplying. So that means we have to see where is the one negative or the other is positive. So as we're moving here 0 to 60, they're both positive in this range, but then after this point our f of x is negative from 60 up until 150 over here. This guy is negative there, and this guy g of x is positive for that range, which means we have a positive all the way from 60 to 150, and this guy being negative from 60 to 150, meaning that a positive and a negative will ultimately give us a negative. So we know this part satisfies our equation, and then we also just need to see as soon as this guy crosses, it means we have a negative, and those two guys will ultimately become positive when they multiply, which means the only part that can satisfy this equation or what they're asking is 60 to 180. So therefore we have to write x is an element. We just need to see, are we included? We will include these different values because we are including 0, because exactly at 60 is 0 here, and 0 times anything is 0. Same thing here at 150, 0 times anything is also 0. So we're going to use square brackets instead of round brackets. In our domain, x is an element of included 60 to 150, and then square brackets here. And that is done. Okay, great. Question 5.5, it says describe the transformations that the graph of G has to undergo to form the graph of P, where P of X equals negative cos X. So this is also 2 marks. So where the graph of G now undergoing some changes to form P of X, and P of X equals negative cos X. So our G of X was this guy over here. So the fact that we need to turn it into a cos means that we are going to have to do some sort of co-function. So I'm just going to rewrite our G of X over here. So in order to do a co-function, we can go one of 2 ways. We can either try and get 90 minus, but that'll take quite a bit of work. So it might be easier to get 90 plus. So what that means is that if we shift this graph 60 units more to the left, we'll end up starting it at negative 90, which means this guy in our bracket will become positive 90. So if we turn this into sine x plus 30 plus 60, we have shifted it 60 degrees more to the left, we then end up with sine 90 plus x. So 30 plus 60 is 90, and I just moved it in front so we could get our standard form for a co-function, which means we then have a 90 plus x. A reminder that for sine 90 plus x, we are positive in our sine quadrant. So sine is already positive there, which means we just take a positive out, and then we can drop our 90 and turn it into cos x. So at this stage, we have a positive cos x, and then it needs to become a negative cos x, which means we'll just have to divide it by a negative 1, and then we end up with a negative cos x. Okay, and all that means in terms of describing the transformation, because this was just showing us the steps as to how we got to this P of X, what we did is we shifted the graph 60 units to the right. So that was over here. And then we did a reflection over the x-axis. So one mark was to describe this portion, and then the other mark is to say when we divided by negative 1, that means we just reflected it over the x-axis. And these would be the 2 marks to describe the transformation that the graph of G has to undergo to form the graph of P, where Px equals negative cos X. And we just earned those 2 marks and completed this section, earning us 8 marks. Great job, guys. Let me know if there are any questions in the comments below, and then I will see you in the next video.